Hello and welcome to my channel. I am Mensah Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we're looking at complex numbers, and under the complex numbers, we'll be looking at the difference between the argument of a complex number and the principal argument of a complex number. Now, let's define in general the argument of a complex number. The argument of a complex number z equal to a plus b are denoted by the argument of z is the angle of inclination between the positive real axis and the line joining z and the origin. So for instance, if I have my complex plane, this is the positive real axis, positive imaginary axis, and I have a point here as z, then the argument in general is the angle of inclination measured from the positive real axis to this line. So the whole of this angle is called the argument. Now, this argument is not unique because it represents set of values. Why am I saying that? This is not the only angle that we can form. Let's look at this. If I stand on the positive real axis, I can come back and land on this one again. So if I complete a circle, I'll come back to that. I can still go back and come and land on it. I can go back and come and land on it. I can go and come and land on it. So the argument is not unique. Now, let us find the principal argument. The argument of a complex number that lies between theta greater than minus alpha but less than or equal to theta, or pi, or theta greater than or equal to 0 but less than or equal to 2 pi is called the principal argument and denoted by capital ARG into z. This is small a. Now, at first, you may think that the definition of the argument can also be given to the principal argument. No, I will tell you the reason. The reason being that the principal argument is part of the argument. The principal argument is part of the argument, but the principal argument is unique. Though it's part of the argument, but it is unique. So, in simple terms, if I draw my complex plane, and before I go here, in symbols, that is how we represent the principal argument. And then I visualize a point here as my z. Here, let's do this one. If I draw this, and I name here, let's say theta. This theta is argument, and this theta also is principal argument. Yes. Why? Because it is being measured from the positive x-axis to this line. But this argument does not take only this value. So here, this argument is equal to this theta plus, if I complete one revolution, I'll come back to that. That is, if I add 2 pi to it, then if I complete another, I've added 2 pi. If I complete another, I've added 2 pi. If I complete another, I've added 2 pi. So here, in general, the argument is theta plus 2 pi n. In some books, they make it k. So that is the argument there. And the principal argument is the theta. That is the angle that we measure. But if we measure in the anti-clockwise direction, we are using this interval to find the principal argument. And note this, the argument is always measured from the positive x-axis. But for the principal argument, you either measured in the clockwise direction or in the anti-clockwise direction. Most of the books use this, and some of the books also use this. So if you are told to find the principal argument, you can measure it in the anti-clockwise, that is the counter-clockwise direction, or in the clockwise direction. But if there's a specification that you are to use this, I'm going to show you. But always, if you have been measuring from here, it means that you are using this interval. I hope now it is very clear. Okay. So here it means that if the principal argument is equal to theta, then we can say that the general argument is equal to the principal argument plus 2 pi n. Very, very simple as that. I've said that the general argument is set of what? Values. Sets. All the possible angles that we can get. Moving from here and then coming to land on this line. In the same way, if it is here, you can move first one, you've landed. But if you go and come back, you will come and land on it. That is adding 2 pi. If you go again and come back, you come and land on it. Another 2 pi. So that is that. Now, let's find this, what you have on the board. Very quickly. So here, for the first one, this is my complex plane, positive real axis, positive imaginary axis. I have negative root 3. So this is negative real axis. And this is positive imaginary axis, 1. So if I put alpha here, I have tangent of alpha equal to 1 divided by root 3, and alpha will be pi on 6. Now, we have alpha to be pi on 6. What is the argument? The argument is equal to what? And the principal argument is also equal to what? Now we need to determine theta. So we have this interval and we have this interval. So we are going to use both of them so that you understand. If we are using this interval, that is this one, you measure theta here. But if you are using this interval, you measure theta here. Wow. Okay. Now let's see. For theta line between 0 and 2 pi, this is what we are using. So from here to this line is 180. That is, we are measuring anti-clockwise. We have theta plus alpha equal to pi in radians. So theta equal to pi minus alpha. And we have pi minus pi on 6. That will give us 5 pi on 6 as theta. So here, the principal argument is equal to theta. That is equal to 5 pi on 6. So here, the general argument is 5 pi on 6 plus all the other angles 2 pi n. That is the general argument. This is the principal argument. This is if we are using this interval. Now what about if you are measuring it this way? If you are to deal with this interval. Now if you are to deal with this interval, that's what we do. If we measure from here to here, we've measured pi. From here to here is pi. But once we finish our measurement, we've measured it in the clockwise direction, so it is negative pi plus alpha will give us theta, because theta is from here to the line, so this is equal to theta. Now once we finish measured theta, then look at where we were measuring to. We were measuring it in the clockwise direction, then it means that theta is equal to negative of minus pi plus alpha. And that will give us pi minus alpha as our theta. So here, if you are to measure it in the clockwise direction, we have theta to be equal to pi minus pi on 6, and that will give us the same 5 pi on 6. And that's our argument will be 5 pi on 6 plus 2 pi n, and the principal argument will be 5 pi on 6. Okay, that is in this quadrant. Now let's check the other quadrants. Now, if you look at this one, we have positive 2 and we have negative 2. So this is the real value of z, and this is the imaginary part. This is the real part and this is the imaginary part. So imaginary part on the on the y-axis and the real part on the y-axis. So let's take alpha. Tangent of alpha is 2 on 2. Alpha will be pi on 4. Yes, that is 45 degrees. Now, how do we take the argument? Before we find the argument, if we are using this, we have to measure from the positive to this. That will give our theta. So here, theta equals, if we add alpha to theta, you will come and land on 2 pi. So theta plus alpha equal to 2 pi. Theta will be equal to 2 pi minus alpha, and that will give us 2 pi minus pi on 4, and that will give us 7 pi on 4 as our theta. So here, this is the principal argument. So the principal argument is 7 pi on 4, and the general argument is 7 pi on 4 plus pi 2 pi n. In some books they make it k. That is, if I go around, I'll come and land on it. Simple as that. What about if we are to measure in the clockwise direction? What will be the principal argument and the argument? If we are to do that one, we have this angle as pi on 4. Now, this angle, we did not measure it from here to here. We didn't measure it from here to here. What we need is that we need this angle. So we use tangent of 2 on 2 to do it. But if you are to measure it using this interval, you have to measure it backwards to this line as our theta. So here you see that theta equal to pi on 4. But after we finish measuring theta, look at where we were moving to. We were moving in the clockwise direction. So theta equal to minus pi on 4. So in this interval, this will be our principal argument. So in this interval, our principal argument will be minus pi on 4, and the general argument will be minus pi on 4 plus 2 pi n. And whenever you check this, they will give the same values. So a quick reminder, it is the principal argument that is being used to change complex numbers to polar coordinates. That is, if you are to fill this R, cosine of theta plus I, sine of theta. The theta here is the principal argument. So most of the books use this, but if it is stated that you should use this, please measure your angle in the clockwise direction. You can check, let's say put 1 here, and then look at this angle, and then You put one here and look at this angle to check whether they are the same. You can check a cosine of the angle and cosine here, and you see that they will give the same answer. Sine and those things will give the same answers. Okay. Now, what about what we have here? We are having only the real parts, -5. So it is on the negative imaginary, only the imaginary part, so it is here. Now, if you are to measure using this interval, then you have to measure from the positive x-axis to this line. And that will give us 3 pi on 2. This is pi on 2. You will come here to pi, and this is 3 pi on 2. Or this is pi plus pi on 2. It will give us this. So if you are to measure this way, then the principal argument of z is 3 pi on 2. And the general argument of z is 3 pi on 2 plus 2 pi n. What about if you are to go this way? That is this interval. We have to measure it this way. Right? So if we find this angle is pi on 2. Yes. Well, this angle is 90 degrees. So it's pi on 2. Now, if we are measuring theta here, theta will be equal to pi on 2. But since we are measuring theta to this, we have theta equal to negative pi on 2. Please note this. This angle, we just look for it, but here we are measuring. Here we just look at the interval between, the angle between this is pi on 2. But here, we are looking at measuring the angle from here to here. It is in the clockwise direction, so it is negative of the angle here. So here, if you are using this interval, the principal argument of z will be minus pi on 2, and the general argument of z will be minus pi on 2 plus 2 pi n. You can use values to check, and you see that they will give the same results. I think it has left with the last one. Now for the last one, that is negative, negative, so it will be on this quadrant. 1 and root 3, so let's put alpha here. The tangent of alpha will be twice opposite over adjacent, that is root 3 on 1, and alpha will be equal to that is pi on 3, 60 in degrees. Now, if you are using this one, then you need to measure from the positive real axis to the line. You measure from here to here, you get pi. Then add alpha to it. So theta equal to pi plus pi on 3. That will give us 4 pi on 3 as theta. And the principal argument of z is 4 pi on 3. Then the general argument is 4 pi on 3 plus 2 pi n. Now, what about if we are to measure in the clockwise direction? This is counterclockwise or anti-clockwise. So if we are to measure, this will be our principal argument, theta. So let's try to figure that one out. So this one, let's look at this. We need this. So we write theta equal to, theta plus alpha will give us 180. Because the angle from here to here is pi or 180. We are not measuring it, we are just looking at it. From here to here is 180 or pi in radians. Now theta equal to pi minus alpha. After we finish finding theta, now we measure theta in the clockwise direction. So it means that theta equal to negative pi minus alpha. And that will give us minus pi plus alpha, and that is alpha minus pi. So we should take note of that. So here, oh, we had what did we get? Pi on 3, right? Okay, that's what we had. Yes, that is what we had. So here, theta will be pi on 3 minus pi. That will give you negative 2 pi on 3 as theta. So here the principal argument of z is negative 2 pi on 3, and the general argument of z is negative 2 pi on 3 plus 2 pi n. Yes, that is this. So this is the difference between the principal argument and the general argument. Thank you for watching. Please subscribe, like, share, and remember to leave your comments. Bye bye.